Assalamualaikum everyone, hope you all are doing well. So now we will start our new topic of physics, that is unit vector. In this we will discuss unit vector, free vector, position vector, null or zero vector. First of all, talking about unit vector, a vector whose magnitude is equal to unity, or you can say 1, is called unit vector. There are some key points of the unit vector. That our unit vector is used to determine the direction of vector. It is represented by letter with cap or hat placed on it, like A. It's a unit vector. There's a cap on the A. After that, our unit vector is a vector divided by its own magnitude. Now we have to prove these points, that how it's possible. So let's move further. Let's take one example over here. That here he said that a vector is used to determine the direction of vector. How we know that a vector is used to determine the direction? A unit vector is used, like we are having f is equal to g m1 m2 upon r square. Now what we have to do, we have to determine the direction of this one vector. We will put over here point, with that we will put r and cap on it. So it will call the unit vector, and this is a direction of vector. Now this unit vector shows the direction of this vector. Number 1 point proved. Now let's move further to the number second. That in number second it said that it is represented by a letter with cap. It's done already, like you can use here A cap, it's a unit vector, C cap, D cap. The cap over on it, it's a unit vector. Okay, now the third one is a unit vector is a vector divided by its own magnitude. Let's suppose we are having A, and this is a unit vector. Okay, now is equal to, this A is a direction of vector and this is its magnitude. Okay, now I am proving that how it is equal to a unit vector is vector, how it's divided by its own magnitude. Okay, so here we are having unit vector, this is we are having unit vector. Now it's dividing here. When it goes here, it will multiply directly. Okay, so what will happen, that unit vector multiply by magnitude is equal to direction of vector. Okay, as I told you that vector whose magnitude is equal to unity, or 1 is called vector. So this unit is equal to 1 and this one will remain same, so it will be 1a, or you can say 1a is a 1a. So magnitude will be a. Magnitude is equal to the direction of vector. This point is also cleared, that a unit vector is a vector divided by its own magnitude. This unit vector is equal to the direction, and direction was dividing with its magnitude. When it move over there, it's multiplied. So this option is where clearly mentioned that a unit vector is a vector divided by its own magnitude. Now let's move further with our next point. In next, what they said, it's just a diagram form. In a diagram form, like if we're having in a space, we are having 3 dimensions, and everywhere we are having 3 dimensions. It's x-axis, y-axis and z-axis. Now what's happening over here, this is x, this is y and this is z. In this one, this is a unit of I. X-axis is called unit of I, y-axis is called unit of unit vector j, and k is the unit vector of z, where it's the MCQs that unit vector of I, j and k are a unit vector which represent the direction of. So the answer is direction of positive x, positive y and positive z axis. This represent the direction of positive x, y and z. Now let's move further to the next topic that we are having, free vector. Free vector. What is free vector? A vector which move parallel to itself and apply at any point is called free vector. Means the MCQs can be that I know that you guys will not understand. Some of them are not understanding the definition. I will make the diagram, then hopefully that you will understand easily. That a free vector, a vector which moves parallel to itself and apply it any point is called free vector. Or the MCQs can be that a vector that does not lies on origin is called. Answer will remain same, that free vector. Okay, now let's solve it diagramic in a diagram figure, that how we have to prove that how it's happening. So let's suppose in a free vector we are having same 3 dimensions. This is known as x, this is y and this is z. Okay, what happening over here, that let's suppose that this is a position, this is a magnitude of a, this is it b, this is it c. Okay, now let's suppose that in a sky a bird is flying in this one position. So what bird do, that every time bird moves in its this one position, parallel position, it moves upward in a parallel position. So from this point it will move to this one point, then this one point, then this one point. So it's going in a parallel position, doesn't lies on an origin. It's moving from one point to another but in a parallel position, so it's called the free vector. With name we can understand that what is free vector. So this is called the free vector. Now move forward with the position vector. Position vector is a vector having magnitude and particular direction. A magnitude also have a position vector means have a position, means having a magnitude and have a particular direction. But this is the definition of some else, like we have to represent it. I think it is a definition of we are having the subtraction, that a vector having same magnitude, not a subtraction. It is a definition of addition of vector, that a vector having same magnitude and a specific direction or particular direction is called the addition of vector. Okay, so vector definition is also this, so it's matching. So there's a one more difference, that a vector having magnitude and particular direction represent with line. A vector having magnitude and particular direction represent with line is called position vector. It's called position vector. Now we will understand with diagram that how it's called position vector. Let's suppose we are having again three directions: x-axis, y-axis, z-axis, x, y and z. And let's suppose we are here we are having moon or any object. Okay, this is a moon. What it's happening, that whenever we are seeing the moon, like specifically we are any occasion like on Eid al-Azha or Eid al-Fitr or Ramzan's moon we are watching. So what we are doing, that we are seeing that, see in that one straight line you can see easily. So it's having a proper line, particular direction, and this is its magnitude. Having magnitude and particular direction represent with a line. This is its particular direction. This is its particular direction. Having line and magnitude, it's called a position vector. Now last we are remaining that null or zero vector. Basically what null or zero vector is, a vector having same magnitude but opposite direction Now this definition shows us the negative vector, as we have done in our previous lecture. A vector having same magnitude but opposite direction is called negative vector. But we have a more one line addition in this, then it will call null or zero vector. Identity of null or zero vector, that a vector having same magnitude but opposite direction with having magnitude, it can be or not, means having magnitude and particular direction means it will have magnitude and particular direction, or not having magnitude or particular direction, then it is called null or zero vector. How? Now we will do it with diagram. I will make a figure, then you will understand easily that our vector having same magnitude. Like I am having a one vector over here. Okay, same magnitude means this is the direction of vector. Direction of vector means having direction, and the magnitude is 4 centimeter. Okay, certain number and unit is called magnitude. So we are having one more direction, it's also a particular direction but in a negative, but it's a opposite, so it will negative is equal to, it will also same magnitude as I said, so it will also have 4 centimeter, same magnitude as the first one have. But now what happens when these both combine together? So it will cancel out, answer will be 0. So what this definition says, that a vector having same magnitude and but opposite directions are having, or opposite direction and or not opposite direction with having magnitude and particular direction, or not having magnitude and particular direction is called null or zero vector. Now let's see, when we will add this both, this will cancel out, but when will we count this both magnitude, answer will be 8. So it means if we are counting, so we are having answer, but when we are adding this both, so answer will be 0. So it will be null, it will call null or zero vector. And hope you all understood. This is a simple topics. Firstly we understood about the unit of vector having whose magnitude is equal to 1. After that free vector means a parallel. After that position vector, we have done with, in position vector we have done with having magnitude and particular direction. In null or zero, having same magnitude but opposite direction with having magnitude and particular direction, or having not particular direction and magnitude is called null or zero vector. Hope you all understood these all topics, because these are the basic of the physics of vector. Thank you so much.